All right, let's talk about something that pretty much everyone with a Windows PC has seen, but almost no one really knows what it is. If you've ever installed a game, you've definitely run into it. So today, we're pulling back the curtain on the story of Microsoft Visual C++.
Yeah, I'm willing to bet this looks super familiar, right? You're all excited to get a new game running, and up pops this little box asking to install the Microsoft Visual C++ redistributable. And look, we all do the same thing. We just click yes and get on with our day. But have you ever actually wondered what in the world that thing is? Think of it this way. It's basically a shared toolbox for all your software. Instead of every single app having to bring its own set of common tools, they can all just borrow from this one central toolkit that lives on your computer. It saves a ton of space and honestly just makes everything work together way more smoothly. But that little redistributable package, that's just the tip of the iceberg. It's the end result of a much bigger, way more powerful tool called Visual C++. So the real question we're digging into here is, what is this thing that's been around for over 3 decades? And how has it been quietly shaping the entire digital world around us? Okay, so let's get right to the heart of it. Before we jump into the history, what is Visual C++? Well, you can think of it as the engine room powering a huge number of the applications you use every single day. So the official term for Microsoft Visual C++, or MSVC, is an integrated development environment. It's basically a massive digital workshop for developers. Its main job is to be a compiler, which is a fancy word for a translator that turns human-readable code into the ones and zeros your computer actually understands. And it's used to build the real heavy hitters, huge parts of Windows itself, graphically intense games using DirectX, and even core components of Microsoft's .NET framework. So let's rewind and see how this all got started. The jump from a simple command line program to this graphical powerhouse wasn't just another update. No, it was a full-blown revolution in how people made software. This timeline really lays out a decade of crazy fast evolution. We start way over here in 1983 with a pretty basic C compiler. By 89, things get a little better with the programmer's workbench, but it's still, just a wall of text. But the real game changer is right here, at the very end of the line, 1993. That's when Visual C++ 1.0 shows up. And that one word, visual, changed absolutely everything. And you can really see the difference it made right here. The old way, well, it was a pain. Developers were juggling all these separate text-based tools for writing code, for finding bugs, for compiling it all. With the new way, everything came together under one roof. For the first time, you could literally draw a window with buttons and menus and have your code editor and bug-finding tools right there in the same program. This wasn't just a productivity boost, it fundamentally changed how software was created. But of course, the world of computing never, ever stands still. As technology went through these massive tectonic shifts, from the early days of Windows to the internet boom and beyond, Visual C++ had to constantly reinvent itself to keep up. You can really break its history down into 4 major eras, and they map perfectly to the evolution of Windows itself. It started back in the 16-bit days of Windows 3.1. Then came the huge 32-bit leap with Windows 95, which meant the entire toolset had to be rewritten from the ground up. Next, it had to adapt to work with Microsoft's big .NET framework. And finally, it grew into the 64-bit standard we rely on today for all of our modern high-performance apps. And right in the middle of that 32-bit era, something amazing happened that pretty much defined how coding would look and feel for decades to come. In 1995, Visual C++ 4.0 introduced this developer studio idea. See this tiled layout with all the different panels? That design was so simple and so effective that its DNA is still completely recognizable in the Visual Studio that millions of developers use right now. The journey wasn't always perfect, though. The 1998 release, Visual C++ 6.0, or VC6 as everyone called it, became both famous and infamous. On one hand, it was unbelievably stable and popular. So popular, in fact, that people still use it to maintain old software today. But it was also super controversial because it skipped a major update to its core libraries, which left a lot of developers who are counting on new features pretty frustrated. Now, all these different version names can get pretty confusing. This table helps make sense of it all. You've got the marketing name, like Visual C++ 6.0, and then the internal version number, but check out this last column. _MSCVR. That's kind of like a secret code developers use, so a program knows exactly which compiler built it. And look how that number climbs, from 1200 back in 98 all the way up past 1900 for the modern versions. It's a perfect little track record of just how much this thing has evolved under the hood.
And that brings us to today. Far from being some dusty old relic, MSVC has completely transformed itself into a modern, cross-platform, and frankly, an incredibly powerful toolset for today's biggest challenges.
I mean, today's Visual C++ is an absolute beast. Developers aren't just building for Windows anymore. They're building for Linux, for mobile, you name it. It has some of the best bug hunting tools on the planet. And it achieved this massive technical goal called a stable ABI. The best way to think of it is like Lego bricks. It means a piece of code built with the 2017 version can snap together perfectly with a piece built using the 2022 version, and nothing breaks. For huge long-term projects, that's a total game changer. And you don't have to look far to see its impact. There is a very good reason Microsoft can proudly say it's used by many AAA top game studios. When you're building a blockbuster video game and you have to squeeze every single last drop of performance out of the hardware to get those incredible graphics, well, Visual C++ is one of the absolute best tools for that job. So from a simple command line tool to the engine running our operating systems and our most immersive games, Visual C++ has had a really remarkable 30-year journey. It's adapted, it's evolved, it's survived multiple eras of computing. And all of that leaves us with one final thought. After shaping so much of our digital past and present, what will it build next?